Okay guys, so at the beginning of the year we did a lot of fractions, and so today we're going to compare fractions, and we're going to do it through a variety of different methods. So when we look at a fraction, say like 3/4, what that means is one whole, one big block is separated into 4 equal parts. Okay, so this tells you how many parts there are total, and then 3 is how many we actually have. So when you look at 3/4, it's not a whole, it's less than a whole, and 3 of the 4 is what we have. Okay, and so if we look at 4/6, that means now I have the same whole. It's the same size whole. It's like the same size candy bar, except this time it is split into 6 pieces that are all the same size, and I have 4 of those 6 pieces. Okay. Now, what you need to know is that drawing the fractions isn't the best way to compare them, because we are not the perfect artist, and there's some fractions that are actually pretty close together. And so we've gone over a couple of different strategies when it comes to comparing fractions. And so let's just review some of them, okay? So when we look at 2 fractions, say we're going to look at 3/6 and 5/6, okay? So one thing that we should automatically recognize in these fractions is they both have the same denominator. That means when I take this whole piece and I divide it into 6 equal pieces, I'm dealing with the same size pieces. So in 3/6, it's 3 out of the 6, and in 5/6, it's here. Okay, so we have 3/6 and we have 5/6, and so it's very easy to see that 5/6 is greater because it has more pieces in the same size pieces. Okay, this is what we call the same denominator rule. Okay, it's the easiest one. So if 2 fractions have the same denominator, you are simply looking at the numerator and seeing which one is greater. Okay, the next pretty simple rule that we have is, let's stay with 6, but this time actually we're going to do 5/6, and we're going to do 5/8. And so in these 2 fractions, we actually have the same numerator, but we have different size denominators. That means we have the same whole, except this one is cut into 6 equal pieces. Trying to keep it the same size, and then I'm going to draw the same hole below it, except this time I'm going to break it up into 8 equal pieces. So I need 4 on this side, and I need 4 equal pieces on this side. And this time I have 5 over here, 5/6, and I have 5/8. And what we should automatically recognize is that 1/6 is bigger than 1/8. And because these pieces are bigger pieces, then this is the fraction that is greater. So when you are looking at the same numerator rule, you're also looking at the denominators and saying, hey, which one has the bigger pieces? Whichever has the bigger pieces is the greater fraction. And the greater pieces are actually going to be a smaller number because it's just cut into fewer amount of pieces. Okay, so that is the same numerator rule. You're looking to see if they have the same numerator, and then whichever one has the larger pieces is the one that is the greater fraction. Okay, so same numerator, same denominator rule. And now let's get into some more complicated stuff. Okay, so we have 2 fractions. We're going to do 3/6 and 3/6 and 5/8, okay? In this fraction, in these two fractions, 3/6 and 5/8, I do not have the same denominator. I do not have the same numerator. But what I do have is I have two denominators that are even numbers. And if it is an even number, then it can be split in half. And so this is what we call the benchmark rule, okay? I simply draw a number line, and I have 0, 1/2, and 1. And it's looking at these fractions and seeing where they fall. And so what is half of 6? Well, 3/6. That means 3/6 and 1/2 are equivalent fractions, and 3/6 actually goes right here on the number line. Okay? Then I look at 8. Well, half of 8 is 4. So 4/8 would go here. That means 5/8 has to go a little bit more than a half. So 5/8 would go here, making 5/8 the greater fraction. Now, one thing, because we have gotten into decimals, is that you can look at these through odd numbers too. Odd numbers can be split in half. They just can't be split evenly. And so when I look at an odd number, it's a little different. So odd number, I could do 2/3, and I could do 3/5. Okay, so I mark my half. Okay, well, half of 3 is between 1 plus 1 is 2, and 2 plus 2 is 4, so 3 is between 2 and 4. Okay, and if 2 plus 2 is 4, then 1.5, I'm sorry, if 2 plus 2 is 4, then that means I have to go less than 2, and so 1.5 is actually half of 3. So 1.5, 1.5 over 3 would be half. Well, 2 is more than that, so 2/3 would go here, right? Because if I was going to break up the number line into 3 equal parts, 2/3 would equal here, okay? Half of 5 is 2.5 over 5. And 3 is just a little bit more than 2.5, and so that means 3/5 would go here, okay? So you can do it with odd numbers. It's easier to use the benchmark rule, though, when you have two even numbers. Putting them on a number line, figuring out what in the world half is, and then is it less than half, is it greater than half, okay? It's a great way to compare fractions. So this last method is probably the most challenging, and it is called the equivalent fraction rule, and it's finding what fractions are equivalent, because numbers get really close. So you have 4/6 and you have 6/8, okay? No same numerator, they don't have the same denominator. They're not one away from being a whole, which that's a rule that we also need to go over. And so we have 4/6 here, and I'm going to write 6/8 here. And what I'm going to do is I can create equivalent fractions simply by multiplying these numbers by the same number, and that multiplies it. So if I take 4/6, for example, and I draw it, ooh, I should not draw it in a circle. And I draw it in a bar, okay? If I have 4/6, and I draw 4/6 again, right underneath it, draw it again. Well, this is 4/6, but when I put both of them together, it's 8/12, okay? And all I did to create that equivalent fraction was multiply by 2, because 4 times 2 is 8, and 2 times 6 is 12, and so I have 8/12. And I'm going to do the same thing to 6/8, right? And so 2 times 6 is 12, and 2 times 8 is 16. And what I'm going to look for is I'm going to keep doing this pattern until either the numerators or my denominators are the same, because I know that rule, okay? So I'm going to multiply it by 3. 4 times 3 is 12, and 3 times 6 is 18. Well, at this point, I can stop, because now I officially have the same numerator rule. I am now comparing 12/18ths and 12/16ths. Well, if I know the same numerator rule, then I know the smaller number has the bigger pieces. So 12/16ths is bigger than 12/18ths. That makes 6/8 greater than 4/6. Okay, so does that make sense? Okay, the final rule, I'm sorry that I said that was the final rule, but this one is actually the rule that I feel you guys are the most confident in, and it is called the 1 unit away from a whole. So I have 5/6 and I have 4/5, and it's determining which one. So both of these are 1 unit away from a whole. That means if I have all 6 drawn, I only need 1 more 6 to make a whole. And in this, I just need 1 more 5th to make a whole. So if this was going to be in a drawing, they're the same holes. I hope we immediately recognize that 5ths are bigger pieces than 6. So I have 5 of these, and I have 4 of these, okay? The thing is, it's the difference in the size, okay? Because 5ths are bigger pieces, it's going to take them a little longer to get to 1 whole, where 6ths are smaller, okay? So I just need 1 more tiny piece in order to make a whole, making 5/6 the greater fraction. So in 1 unit away from a whole, if both fractions, both of them have to be 1 unit away from a whole, the bigger number in the denominator is going to win, because it's always the smaller piece. So these are all the rules for comparing fractions. I'm going to be placing some problems below this video for you to practice at home using these strategies. Please make sure to take a picture of all of your work and to upload it to It's Learning.